All right. Good afternoon, everyone, and we can get started. So this is Digital Strategies. My name is Sanjeet Sanghera. I'm the head of grids and utilities at Bloomberg New Energy Finance. We're a strategic research provider covering the entire low-carbon value chain. And today I want to talk to you about digitalization, grid modernization across the whole value chain, from the substation down to the retail side. And I think this year is a particularly interesting time to be having this conversation. So I'm a power systems engineer. I've been working in this sector for over a decade. And I think 2023 has been quite distinct for me. Keen to understand if it's been the same for you. So we've seen a number of things that normally have been discussed, maybe in rooms like this, but they have really leaked out into the public, right? So we saw The Economist publish an article with a man hugging a transmission tower, right? Things like this. And although the discussion points in these publications are maybe similar to what we've been already talking about, now that it's in the public sphere, it's really started to snowball and get money into electricity grids, gets money into these utilities' hands. And so I think revisiting the question of what the strategy is, where should we be directing our time, attention, and all of this new capital is quite important to do. One thing we do at BNEF is we build out a scenario for net zero out to 2050. And no matter how we build it, no matter what assumptions we put into this economic model, what we find is that this decade ends up being crucial, right? If you want to be Paris aligned, you end up having to move quite quickly this decade. So spend on the electricity grid, and that includes digitalization and modernization, generally has to double and sometimes even triple depending on the market. And so this is our modeling. Are we actually seeing this in reality? We are, right? So there are multiple markets now in Europe that have started to do this scale up. And so there's a sense of responsibility there. And that's to me is the context for this conversation, is to then now figure out, well, what are we going to do with this? Now, building out the grid from a traditional perspective, putting copper into the ground or putting aluminum into the ground is important, and it needs to be done. But supply chain constraints have come up. And so the need to be able to use the system we have as efficiently as possible is absolutely crucial. I'd like to now introduce my panel to have this conversation about what we can accomplish and what the technologies are. So we'll have a little bit of discussion of where we stand today with regards to digitalization. I'd like to talk about the architectures that we need to carry us forward and some of the kind of more technologies on the frontier. To start, if I can ask each of the speakers to maybe introduce themselves, their company, and provide a bit of opening remarks. Stuart, can I have you start?
Okay, so my name's Stuart Thompson. I lead electrification service for ABB. What does that mean? We look after about 12 million sites around the world, across 52 countries, where we have installed base of ABB and other people's equipment as well. We have field engineers taking care of those assets from the time the customer receives the product and through that 30+ year life cycle of that product. The offer that we give to the customer is around caring for the product at the start, but then looking to do modernization and upgrading, or advice around consultancy in moving your products from analog to digital, digitizing the network, modernizing your asset and your fleet. We use various types of tools and systems to do that, but we run one of the largest service networks globally, whether it's from medium voltage all the way down to the house. About 40% of our business is utility-based, about 40% of it is heavy industrial, and about 20% of it is through buildings and high-tech data center type work. So we work across the entire value chain of digital today. And we're helping a lot of companies and customers and utilities become digital going forward to manage those assets that Sanjeet just talked about. So with that, I'll hand it over. Arnaud.
Thank you. So my name is Arnaud Cantin. I'm working at Schneider Electric, and I'm leading our digital power business. So this is a business line within Schneider Electric which takes care of all the digitization layer above power infrastructure. So we are talking about smart connected devices like production relays, metering, and controllers for the power domain, as well as software solutions to glue all of it together and answer the growing needs vis-à-vis digitization. So this is a business that we do in many end-user segments as well, going from power and grid utilities to critical infrastructure, commercial industrial buildings, and advanced industries. So pretty much all type of end-user facilities and installations. And our power and grid business and strategy is very centered around the virtualization of the substation, production, automation, and control. So this is one of the big topic for us at the moment, so enabling the flexibility that the grid need at the substation level within the utility space, while our other colleagues from Schneider Electric in digital grid are taking care of the grid management systems that interact together with the substation level. Voilà, so that's who I am.
Good afternoon, my name is Claire Vast. I'm working for Enedis. Enedis is the biggest DSO in France, operating in France. I'm the global head of data of the company, and basically my job is to make possible, and in a way which is efficient, the building of data services, both for the market, to help the market to work, and also to ensure that the company will be more and more efficient.
Great. My name is Neil Golhar. I'm the Chief Product Officer at Kaluza. At Kaluza, we're a software platform that helps energy retailers transform their operations. So everything from collecting metering reads to device management to billing, managing the customer lifecycle, as well as a number of EV managed charging programs that we have in the market. We operate out of Europe, US, and the APAC region.
Hello, everybody. My name is David Sykes. I'm head of data at Octopus Energy Group. Octopus Energy Group is the parent company of Kraken, which I think if you've been walking around today, you'll have probably seen lots of pink octopuses, pink fairy octopuses. So Kraken is also a digital utility platform. It was sort of born out of a need to build a platform that could help retailers, asset providers, deliver really great customer service that's centered around sort of incredible customer outcomes, but also be able to deliver the modern set of products and services that are going to allow retailers and utilities to really make use of all the assets at the edge of the grid. Yeah, and I look after all of the sort of data discipline there.
Good afternoon. My name is Juan Luis Martin. I am the Director Head for Energy and Utilities in Middle East, Asia, and Pacific in Minsight, the digital transformation IT and consulting services company for Indra. I would define my company as an expert on real-time mission-critical systems, applying for many, many sectors. In the energy and utilities arena, we work for more than 500 utility companies in more than 90 countries, actually. We are working in the whole value chains for the utilities arena, from power generations, asset management, asset predicted maintenance, to grid control, including DERMS, digital and virtual substations, smart metering, and grid and smart energy services for the new digital trends. Okay, we invest more than 300 million euros every year on R&D, working on all those digital technologies that my colleagues are also applying, develop our own solutions, and trying to work in a cooperative way with even every day more stronger partner ecosystem.
Good afternoon. My name is Sozon Kokinaras. I work for Trillion Networks, an American/Canadian based company that provides telecommunication solution to utilities. It enables the digital transformation by collecting the data from the field devices, bringing them back to the utilities data center. My role is Director of Customer Operations, currently supporting the APAC region. So I'll try to bring a perspective from a different region on digitalization strategies and project implementations there.
Okay, so I think with that, you'll see the range and depth of knowledge here, both across markets and also across the digital value chain. I'm going to start off asking a few quick fire questions, and then we'll go into a main round of questions. And then we will take questions from the audience at the end as well. So if you have something that you would like to ask, please start thinking about that. To start, I want you to put up your hand if you agree with the first adjective I'm going to use in a statement, or if you agree with the second one, you can put your hand out like this. So the first adjective is this way, and the second adjective is in front, okay? European digital architecture, is it advanced or is it outdated? Is that Claire? You're saying outdated or
I'm in the middle.
In the middle.
It's not like this.
Not allowed.
Consensus there seems to be outdated. Okay, second question. The pace of digital transformation in Europe, are we accelerating or are we stagnating?
Yeah.
Interoperability, is it currently sufficient or is it deficient? Telecommunications build out, is this an urgent priority or is this secondary? It's a bit mixed. Smart meters, are they fundamental or are they overrated? Okay, got two more, and these ones get a little bit funnier, but let's see. The cloud transition for utilities, is it inevitable or is it overstated? Oh, really? And AI's role in the utilities, is it fundamental or will it be supplementary? I'm a bit mixed. So we have an outdated European digital architecture that is accelerating in its digital transformation. Interoperability is deficient. The telecom build-out, we don't really know. It's either urgent or secondary, so it's a bit mixed there. But we know that smart meters will be fundamental. The cloud will be inevitable. AI's role is a little bit more ambiguous. All right. So with that, I'm going to start off with some questions. And Stuart, Arnaud, the first question is for you. I'm wondering if you can start to classify the markets in Europe for me a little bit. What does that landscape look like in terms of digitalization? Are there leaders and are there countries that are really picking up the pace more recently and have started to move more quickly? Maybe Stuart, starting with you.
Yeah, well, from a global perspective, to Claire, I think Enlight is leading, right? When it comes to digitalization in utilities, there's been some analysis on a global basis. If we looked at Enlight here, we looked at Taiwan Power Corporation, a couple of utilities in Australia and in the US like Con Ed. These guys are leading in the digital transformation. But there's a whole lot of countries that are falling way behind at this point in time. So I definitely see that as the trend. Enlight is leading here in France. Fortunately, we're here in France today. But they are taking that boundary. But there's a long way to go for these utilities for sure, going forward in the market.
Thank you. Arnaud, would you add anything?
I'd probably add UK from a number of perspectives because of the advancement, I think, in the interaction between the field level and the grid management level, where we've seen maybe more advanced proof of concept or deployments from that perspective. Just as a complement, is for me what I've found to be a quite advanced place as well, for sure.
Okay, so Claire, entities was mentioned there. And
yeah, we are number one in terms of smart grid. So yeah.
So what would you say it means to be a data-driven organization? Like, what is it? How have you embedded that into your strategy?
Yeah, data-driven for me and for Enedis means that we do everything that we have to do to ensure that the data from service from data will be built efficiently. That's the key word, both for internal performance or efficiency, and also for, Enedis play a very specific role to enable the market in France. And we also have to provide data and services to all of these stakeholders. So we really have to, it's not that we have not done a lot of already very good data services, and I will provide some example if you want later on. The point now is to be able to do it efficiently, meaning that we have to concentrate on building the services and not trying to grab the data, ensure that the data are at the right quality and so on.
Maybe a bit of follow-up there. The French grid is a different one. I would say there's a high percentage of rural electrical load. We called this radial back in Canada, where I was from. I think call it antennae type system here. Do you feel that the digitalization was necessary for your specific type of power system, or was it a choice that was made and you could have gone down two different paths? Was it a necessary thing you had to do?
What do you mean? I mean, working on data, you mean, or?
The modernization of so France modernized quite early, right?
Yeah,
so
the point is that, we have to do it because we have more and more renewable in the grid. If we look at the number of that I look at the data, of course, but if the average curve of the data that we'll have to process in the future, it's growing a lot. And why? Basically because people are going to use more and more Linky, which is the French smart meter, and that's bring more data. Because the grid will have more connector inside, equipped with more connector, we will have more data. And if we, as you said before, if we don't look at this now, we will be in a situation within a few years from now where we will have a lot of difficulties to handle this, all of this information. So I really think that it's required to digitalize the network.
Okay, Neil. So if other companies, utilities are looking to follow, what challenges do you think they're facing today?
I think one of the challenges is we talked to a lot of retailers at Kaluza and utility companies, and I think one of the biggest challenges with transformation, digitization, whatever you want to call it, data, is just being really, really clear about what's the outcome you're trying to drive. I'm an engineer by trade, so I think of everything in equations, right? And the simple equation I like to present, when we're talking to a retailer is what is the difference between how much is it to serve your customer versus the gross margin you're making off of each customer, and you multiply all of that by how long does that customer stay with you, right? And oftentimes when I'm talking to utility or retailer executives, they say, you've got 10 chips. Where do you want to place those chips on that equation? Because that is actually what's going to define where you need to digitize first, where you need to transform first. Now, the usual answer I'm usually met with is, Neil, that's impossible. I can't place those 10 chips across this. I need to put 10 chips on each of those. And oftentimes what it comes down to is simplifying the business. Oftentimes when you're talking to retailers about this equation and getting more customer lifetime value, the number one thing that you can do is just simplify the business. So if you have 500 tariffs that you're offering your consumers, boil it down to 10, and then digitize the business and transform it, because simplicity is your greatest friend when it comes to digitization. If you simplify the business, the data becomes easier, everything becomes easier, and then that becomes your foundation through which you can build on top of. I don't know if that directly answers the question, but it's just some of the themes we see a lot across
Fair enough. If, David, you can continue on, looking at more of the retail side, you guys operate in, I think it's 14 countries on your website across the value chain. Do you see any differences in the data strategy of these different markets that you're in, working a bit more downstream?
Yeah, sure. Just to pick up on that last point about like the challenges we see in the retail sector.
Yeah.
For most companies, so when the utility space talks about data as a sort of nebulous thing, data is about visibility, better decision making, and building great products on top of it. And you can't understand and optimize your system unless you can see it. And whether that's a retailer or whether it's a network or a grid, if you can't see it, you can't optimize it. So the main challenge we see is that many utilities have there's sort of all the gear, no idea is how I put it. They have all the systems they could possibly need, but they're fragmented across sort of 16 different source systems. And then trying to make decisions across that, or just ask simple questions across that data value chain is impossible for them. And even when they're starting to layer on like even more expensive tools like your Snowflakes and your Databricks on top of that, they still can't do it because all the data is so siloed. So the main challenge, I think, is getting your data into a system. And I think the world is going to get more complex. So in the UK, we're going from a world where you could think of, you had 14 different customer archetypes, basically, because everybody was profiled to the same profile. We're now moving to a world where everybody has their own profile. Their gross margin is unique to them because they're using energy at different times against different tariffs. So you have to do a very complex calculation. So really, utilities need to put, and retailers need to push to get their data into a modern system so they can start to basically make sense of it. That's what we see. And I guess in terms of like the difference we see across regions, certainly at the retail level, the main differentiator is the amount of smart meter penetration, and that tends to be governed by how governments went about approaching it. So the UK took a sort of supplier-led, sell it to the customer approach. That has got inevitably very well for the customers who want it, sort of 50–60%, and is not going so well for the remaining customers who don't really want them. Other countries have taken a sort of DSO infrastructure-led approach, which is actually in France been a better approach to getting it across the space.
Does that resonate with everyone? Like, I know you're working at various parts of the value chain, but Stuart, Arnaud, are those principles still true for you guys?
I think the complexity is going to get more. Exactly what you said. There's more and more data coming, and there's more and more opportunities to measure further down in the system. The sensor technology today and what we can measure and what we can integrate and modernize into the grid, we can measure down to things that we never even thought about measuring before. The level of decision making, though, we are seeing happening further down in the process, so that you're making the decision at the site, at the location, and you're processing much closer rather than feeding all the data up, because the amount of data is just huge that's going up in the system. So, but I still see a huge modernisation issue. There's a lot of utilities out there that have still got analog devices, still haven't implemented the sensing and the technology to really make it effective. But I still agree, the amount of data coming up and using that data, not in a silo, but in a collaborative way to make smart decisions, we don't see that happening a lot. I don't know.
That's a key issue for us, for instance, what you just said before and what you say. It's the place where we are going to spend a lot of energy right now. So it's less sexy than machine learning, AI, and so and so, but it's critical if we really want to be able to grab the value from this data. And it's not, we're not going to grab the value by silo. We tried already, and we spent a lot of time trying to enrich this silo, this data from this silo, with data coming from somewhere else, because the real life is going more complex. And for handling this complexity, we need to have a view by collecting data from different silo, I will say. Different silo is a kind of business line. So we really have to do that. And in order to do that, the very first step is to explain that inside the company. And it's not so easy sometimes to convince that we have to spend a part of the money, a small part of the money, just to really build this foundation. That's really what I have to do right now.
Maybe reminding also on what Stuart was saying, we are seeing also a bit of a change of paradigm between, there's been a lot of thinking in the past around, centralizing a lot of data, and that's still necessary, no doubt, but it's also, how to have the intelligence at every level, right? And so having that, intelligence run locally, but manage and deploy centrally, I think is a bit of the shift we are seeing nowadays with the most maybe advanced utilities in their digital strategies, is how we manage both the intelligence at the automation level, the intelligence at the grid management level, and the intelligence at the enterprise level, and how they interact together. So how can we learn maybe through the cloud, because there are much more capabilities there, but then you need to be able to deploy those schemes. And so not bringing too many data which may not be of so much value, or pre-processing them at the edge before sending to central systems, and then vice versa. Deploying schemes from central into substation, from with a remote and centralized approach, can make things much faster. And I think the change of paradigm is that if we keep building upon the type of solution that have been existing so far, it cannot go fast enough for sure, and there will never be enough capex as well. So this means different type of solutions that can be much more managed centrally but deployed locally as a key enabler to instrument, automate substation for what needs to be there, and then you have the right connectivity pipes into the enterprise level systems.
Yeah, so I do want to come back.
Yes,
go ahead.
What I would say, I fully agree with many of the things that my colleagues are saying here. First of all, it's clear that there is no choice for the digital transformation. Second point is that you must do it in a very efficient way. Okay, if not, your managers will tell you something. But the main thing is that you have to put real focus, okay? Because there is no limit on technology, and the possibilities, again, are fully unlimited. There are a lot of initiatives in many utilities. They are doing some pilot, as you mentioned, but at the end, what you are getting doing pilots here, here, and here is to create the silos that the digital transformation must prevent. This is the situation that we had in the past. This is the situation that we had to prevent. At the end, we also mentioned that with the digital transformation, you must improve and simplify your smart services. Okay, and it's clear that there is a big heterogeneity in all over the world. The problem is that you have to adapt your digital strategy to your own concern and to your own pain points. The best things that you can learn hearing and listening what others did is what to avoid instead of what to do, because you have to apply the digital transformation capabilities to your own possibilities. Because in many, many places, when I am visiting many clients, looks like that they are inventing problems for new solutions, and it has to be exactly the opposite,
Interesting. So I'm gonna come back to this, at least like this question of architecture, and I think I had a sense of what it was, and now I'm more confused on what the ideal architecture needs to be. And maybe there isn't one answer to this question. But Sozan, I want to give you a chance to comment on that initial question around the telecom build-out. We got a bit of a mixed answer. Maybe if you can elaborate on what you think the status of the telecom system is in the markets that you're working in, and why we would get such a mixed answer, because it doesn't seem like it's getting the same level of clarity that we have on some of the technology applications.
Yeah, there are several technologies, right? So Europe has a lot of countries that they have invested a lot in the power line communication technology. It was developed here, so it's loved. A lot of countries, because they use cellular, because the link between the ownership of a telecommunication or telco company and power utility, it make it affordable. In India, for example, cellular network and the tariff, it's so cheap that there is no incentive to use any other technology other than cellular. There are North American countries and Asia-Pacific countries I work, they are going for an RF technology. So RF mesh has been deployed. In Malaysia, for example, we have 3.5 million meters deployed using an RF mesh technology, and it works pretty well. It meets the customer objectives and goals.
Okay, so there's a mix of technologies, and they seem to be meeting customer needs. Juan Luis, you work in some of these other markets in the Middle East as well. There's this idea that with digitalization, that we might even be able to leapfrog in some of these markets, right? That the markets that didn't digitalize at all, that they can just go right away to the newest standards, the newest solutions, and they don't have to go through this painful process of brownfield redevelopment, and they go straight to greenfield. Okay, so is that real? Like, have you seen this actually happen, or is that just kind of an illusion that we think could play out?
It is a reality in some countries, not in all of them. Okay, for sure. All the developing countries do not have the same constraints that we have here in Europe with biggest former investments that we have to think what to do with them. They have no limit on the new capabilities for investments on the grid. They have a lot of capabilities for power generation, talking about renewables with solars, but also they still have a lot of research for fossil power. And with those points, what they can do is, again, as I said earlier, not look at what we did. They can be, in the very short term, in a much more advanced situation that we can do now, because they don't have constraints.
So when you say they, you're referring to?
Well, I am talking about the most advanced Middle East countries. There are other countries that the first thing that they had to guarantee is the supply. Okay.
Okay, interesting. Yeah, I think that comes up in telecom as well, right? We've seen it play out in the telecom world, where, like India, for example, moved quickly into everyone having internet, and they didn't put copper in the ground to achieve it, right? And they did it through a new technology. Okay, let's come back to architecture. I'm keen to Stuart, to maybe get you to explain to us, and Neil, your take on this would be important as well, to get it from both sides here. But what are the different architecture types that are available here? And can you maybe just talk through what you're seeing utilities come to you with, and like what situation are they in, and what situation do they want to get to? And because I think there's a different pathway, and not everyone is in the same condition, and nor do they want to all move out into the cloud necessarily, right? And so map that out for me.
Yeah, so in ABB we offer the full cloud-based solutions, of course, for utility customers. We can also do virtual relay settings and everything in the cloud. But what we saw in the last 18 months was a significant concern about energy security, cybersecurity, stabilization of country policy and geopolitics paying out pretty well. To the point about managing the enterprise level down to the local level, we're starting to see a lot more development around on-premise and edge-based computing technology, right? a lot of upgrades and development in smart devices. We can take sensors now for less than $1,000, apply them to a transformer, and understand the dynamics of a transformer that 5 years ago we didn't even bother monitoring. We can get that data very quickly. I was in China last week and we were looking just at thermal sensors for less than €15 on bus bar systems. So there's a lot of data collecting at the low end now, and a lot of utilities and industrial customers are wanting to measure and analyse that data and install it in a brownfield-based situation. But all that data collection, they're wanting to make decisions at the site, at the location, and it's only the exceptional data that starts to go up in the system from there. So they're making predictive analytics, it's doing it locally, there's a lot of data there, and they're managing it at the site. But they want a scalable solution, so they want to go from the on-premise, the edge to the micro-cloud, the cloud, micro-cloud to the cloud. So we see a lot more development at that edge computing level, and we've been working with a company called Protexo, very innovative in this space, working with Norwegian utilities, working in the US, to come up with edge-based solutions based on exceptional data, decision-making around exception rather than masses of data, and making decisions quickly. So edge computing is a big one for us. A lot of new sensing devices that measure just functional changes, just so that the crews can go out and analyse things quickly and make decisions quickly. So from a services perspective, we're upgrading a lot of systems on the brownfield side to do it both from a sustainable perspective, so keeping all that infrastructure and that in place, utilising that copper, that steel, those frameworks of equipment, and just putting in the Internet of Things devices into the existing infrastructure to minimise your carbon footprint as you're doing this, and then continue that asset running on for years as well. So from an architectural standpoint, we are seeing a lot more local data, edge computing becoming huge, not just in utility segment, but autonomous driving, mobile phone data and information. So we see that growth happening. And then if the cloud wants to pull that data further up, it's there and available to go up into the network. So I'd say edge computing is the biggest push for us in the next 12 months.
And so maybe, Arnaud, you're nodding your head a lot. And so do you agree? Are you seeing the same? And I'm keen to talk to Neil and David as well, because the computational needs might be different for the problems that you guys are looking at. Maybe the cloud makes more sense on certain applications. But maybe, Arnaud,
yes, nodding a lot for sure.
Yeah.
We are seeing a lot of, one of the reality that we are facing is that most of the capacity is built in general and is limited. When I see, I'm thinking about the infrastructure capacity. Right? So when we talk about infrastructure capacity, the amount of electrons that can flow through the system are limited in nature. Yes, there are investments to upgrade lines, to put new substations and so on. However, for the vast majority, that capacity we need to consider as fixed. And creating the flexibility at the local level is of utmost importance. And that's why I think we're also seeing this move to edge. We were talking about architectures. Our difficulty to sometimes move from where we are to where we want to be in the future. Well, the reality, if you take the secondary substations, is that most of them are just not instrumented at all. No controls, no monitoring, or very specific, one smart meter connected to a siloed system, and that's it. And then maybe you have a RTU to manage the MV loop. That's all. However, now you start plugging a lot of not only renewables, but also EV chargers. Europe, I think it's what is accelerating the pace big time. Now you need to start managing that low voltage side of the substation with interaction with the medium voltage that's feeding that and its capacity, right? And I think just building on what Stuart was saying is, okay, we absolutely need that intelligence because it can only be there. Now you also need the cloud because you'll need to train your models or deploy your schemes from there, right? And so that connectivity needs to be established so that the necessary data can flow upstream for the training, the learning, and deploy that back down. in a scheme that is optimized and doesn't need so much data flows, because data are expensive. Yeah.
Okay, but yeah, Neil.
Yeah, I mean, architecture is a broad word. There's a lot of different kinds of architectures, data architectures, edge versus cloud. The space that we play in, I think we typically see kind of two extremes, right? So you've got, in software platforms, you have sort of monolithic platforms, right? These often come under the guise of one-stop shop. All the data is centralized in one place, all the applications are in one place. I used to work for Oracle, so this is very much the Oracle play, right? We'll give you everything that you ever need. So that's one extreme, right? That's monolithic. And then you have sort of highly decoupled system, microservices, right? Where everything is decoupled, everything is sort of a unit of work that you can do. That's problematic too, though, because then you have to do a lot of work to put those microservices together to actually get some sort of outcome out of it. We think the right sort of architecture is somewhere in the middle, that it depends. When it comes to core things that need to be done, for a retailer to serve its customers, that should just work. But when you think about the edge of the system, right, the ecosystem, so a lot of our retailers we work with, they want to work with auto OEMs, they want to work with solar inverters, they want to work with storage companies because they want to integrate that data into their software platform. Well, you can't be monolithic. When you're working with other ecosystem partners, you have to be extensible. And one of the phrases we often use at Kaluza is we need to be extensible around the edge. And it's for that very reason, because we do need to integrate with auto OEMs and solar inverters and storage devices to pull all that data in. But I'd say that maybe that's just one paradigm, sort of highly microservices versus monolithic platforms.
Okay. David, keen to get your thoughts a bit here. Like, you guys have, is it like 700,000 turned down service customers, right? And so, maybe shifting to talk about data architecture and what digital strategy you guys need to use to enable service of that scale and have it operate efficiently. Can you walk us through what that has looked like?
Yeah, sure. So, on the architecture debate, I think we think about sort of outcome rather than architecture. So ultimately, utilities are looking to migrate fast off legacy sort of fragmented systems so that they can offer these really interesting like smart, dynamic, managed propositions that can help leverage all the flexibility that's in the system. And we found that the best way to do that is to build a system that has an exceptionally good conceptual model of the world. So if you look at sort of old systems, and I won't name names, but some of the sort of traditional billing engines, they've been adapted from old world. Often they've come from outside the energy space. They might have come from automakers or the chemicals industry, and they've been adapted to work for an energy system. And we think if you have that really great conceptual model and effectively a really great operating system, then you can plug lots of stuff in at the edge, but you plug it in through well-governed and well-maintained APIs. So when we manage, so we talked about that 700,000 customers doing turn down, that's done through our cloud system. We're basically distributing a bunch of events out to the either through SMS or through push notifications to apps. And really, the utility sector is lagging many years behind the technology sector in terms of the scale of the kind of things it's going to have to do. So we can leverage the tools that are provided by cloud providers because they've used that at scale on problems which are much bigger than ours. So we don't actually have to worry about the sort of tooling. It's more worrying about like how good is your model of the world and how well does that map to what you actually want to achieve as a utility. And we've found that many of our clients have been able to do stuff they just couldn't do. So for example, one of our UK clients just physically couldn't do a smart EV tariff and couldn't do a half-hourly settled tariff. And they came onto Kraken and suddenly they could do that because they have this new model of the world that they can work with.
Claire, moving to talk about a little bit more of these applications, as a utility, if you could talk through some of the AI applications. So this usually takes you into the cloud. I know Enlit has done a few of these. Can you talk through what you've done and what the gains have been in delivering those?
Yeah, perhaps I just want to react off the previous one.
Yeah.
I guess depending on what you are looking in our activity, you are more in this side or you are more in this side. Meaning that, of course, edge computing will have a lot of value, probably not just now. We have a lot of things to do, a lot of things to try to ensure that we grab the right data and we are able to sample at the right level, let's say, locally. Yeah. We have a lot of things to do, but this will have probably a lot of value for, I don't have the word in English, to ensure that everything is okay at the low voltage. And what you was just saying before, we have to build a digital environment where we can work with others as extended company. Yes, that's absolutely true in all other kind of business. When you are working with your parties or stakeholders, you have to build your environment to be able to share and sometimes to work at the same place together. That's also, so it really depends what you are looking at. Now, coming back to the artificial intelligence, I will actually not talk about artificial intelligence, but much more about machine learning, sure, which is much more precise. So we have done many different things actually on this field. I just going to give two examples. One is related to the fact that we have a large number of overhead lines that we have to check. And for doing that, we are using drone, and then image processing, and then machine learning in order to detect equipment on the poles, and also to detect some default. And it has a lot of value for us. We have 320K kilometers of such lines that we have to inspect, and it saves a lot of money if we can use drone instead of helicopter or other things that we was doing before. And we can do this because actually we have access to drone image processing and machine learning. And it's important for us to ensure that we have the knowledge on the model, the machine learning model that we are building. Because over time, this kind of models can just change. They can become less accurate than at the very beginning. We have to observe them to be sure that they will still at the very high level. And if not, we have to be sure that we have data, we have stored the data to retrain the model. Okay, that's completely different in the way you are looking at data and data treatment compared to what we've done in the past. It's completely different. It's not the rules, and the rules will not change. It's a probabilistic or stochastic model, and it could change, or it could adapt to the reality which is changing. Another model is, for instance, a place where we have used large language model, which are very well known now by everybody, but which are not new, really. And of course, we are not using a huge ChatGPT language model. We used some open source language model. We trained them into our own vocabulary. And we use them in order to analyze we receive thousands of requests from the supplier every day, and a large number of these requests are not very well defined. And we need to figure out that to make a separation between the requests which are correct and the one which are not. If not, we send people in intervention, and then when they arrive on the field, they figure out the solution. It's not clear what they have to do, for instance. And then we pay money for nothing. So we use these LLMs to really analyze all the data, which is text, which can be other kind of data, cross all together and compute some scores to the supplier request, and ensure that when we send somebody on the field, it has a value. And actually, we collect if the model was correct or not. And using this, yes, you're right, no, it's false, then we can retrain the model to make it more accurate.
Interesting. So I like those examples because they're very different. And it shows the scope of activities that companies in the power sector are having to wrap their minds around and build data models that solve these types of problems, but also those types of problems. It's not simple. Juan Luis, one of the things that Claire mentioned is generative AI in this kind of conversation. I get an inbound inquiry on this like quite frequently about the role of Gen AI in the utility space. What will it do? Are you getting a similar interest from clients, and how are you answering these questions? Is this a distraction? Like, I think it's on the minds of probably a few people here, so I thought we would just address it if it's been brought up.
I would start saying that I work for a technology company, so my duty is to sell as much technology as possible to my clients. So formally, I should say, yes, of course, this must be the core. But the reality is that you have to define your business model. I fully agree with Claire. Gen AI is a very promising technology. We are implementing very relevant pilots in an interesting number of countries, in US, here in Europe, also in Middle East, using artificial intelligence technology. But do you really need those advanced artificial intelligence? Maybe with some smartness is more than enough for your current painfuls. It's to say, you have to keep an eye on the future, because you have to define your clear roadmap, but put your foot on the ground in order to see what do you need. I keep a lot of discussion with my clients, because they are always interested to know what advanced solution can they define, and how to be on the cutting edge of the technology and to be a real example for the rest of the world. But okay, we can do some pilots. Why not? We have the capabilities to do it. But if you want to transform your business, first of all, put what you really need now to improve and to get your operational efficiency levels.
Okay, I appreciate the honesty in that answer, honestly. Maybe shifting to a technology which I think is actually core, which is smart meters. And Susan, I just wanted to get your take here. I know you're involved with the smart meter rollout in a few very large markets, so with TNB in Malaysia, in India as well. Yeah. What will smart meters do to these markets? Like, how important is it to get these meters in? How does it start to transform a market once they're there?
Well, smart meters is fundamental to the digital transformation of a utility, right? They provide reliable data that allow utilities not only to bill the customer, but to make decisions about the grid management, purchasing of energy on the right time. Allow them to offer services to the customers they couldn't offer before, like time of use or insight into their consumptions that allow them to change their consumption habits and save money. You know, very important with the rate increase, the tariff increase we see, and the energy pricing that we see the last couple of years, right? It's very fundamental, smart meters, in my view, for distribution utility. Is it easy to deploy and you know, roll out? Not always. It depends. Basically, it depends on, and sometimes it's very political as well, right? You know, so for example, what we see in India, it was very quick. You know, they deploy 1 million meters within 2-3 months, basically. You know, because they will just go to somebody's house, the meter is outside, they will go and rip off the old meter, will put a new meter, and that's it. In markets like in Malaysia, it was more political. They had to make sure the customer accepted first, right? So they had to go through a community engagement. They gathered the community, they told them why they do it, what's the benefits. They had to sell it to the consumers before they were able to roll out on each region, on each particular area they wanted to deploy. So quite interesting, different countries, different approaches, but the benefits, I think it's similar basically to all countries. Some, they try to resolve different problems as well, right? So in the development world, you will see a lot of energy theft, right? So this is definitely something that they're trying to avoid. And if you think about energy theft, potentially you can recover, a utility can recover the whole investment of rolling out smart meters just by the reduction of the non-technical losses.
So David and Neil, it's been a bit rockier in Europe, I think, right? So the cost-benefit analysis for smart meters hasn't always yielded a positive outcome. I think we've revisited that and things seem to be moving more smoothly. How do you guys view the value that meters provide as we digitalize?
So we see them as sort of fundamental, and really, for me, it's about connecting system value to customer value. So in a system where you're just billing every month, it's very difficult to apportion the value a customer has by taking a certain action or charging their EV at a certain time to the value that adds to the system. But there are billions and billions of pounds, dollars, euros being spent just balancing systems, turning up turning down nuclear plants for whole summers because we've got too much power, or bringing in power across interconnectors, and consumers can provide that system value very, very easily by shifting their load around. And some of our customers, our clients of Kraken, have shown that to be the case. In the UK, the distributed flexibility service has done millions and millions of customers have turned down at peak time. And the smart meter is just a piece of infrastructure that enables that value. And markets have tried to sell it through, and the UK did this early on, they tried to sell it through personalization and, hey, here's this cool smart thing on your wall and it'll tell you about your usage. It's really not about that. It's about how do we make the billions of pounds of customer money that the system operator spends in the market, how do we get them to spend that back into customers so we have this sort of circular cash flow, and then the whole system is cheaper as a result.
Yeah, I think when smart meter, I've been part of the smart meter journey for a few decades now, going back to my time in the US. And I think when companies are explaining the benefits of smart meters, it's quite ambiguous to customers. But with, whether it's load shifting, or one of the big ones that we're really focused on is exporting back onto the grid. So we've got about 400 vehicles in the UK. It's the biggest vehicle to grid program in the world for residential customers. And those customers are exporting energy back onto the grid. Some of those customers are saving £1,000, over £1,000 a year, right? Using the smart meter and exporting energy back onto the grid. Those are not just the most engaged consumers, right? These are everyday customers who just went and bought a vehicle and just happened to be a vehicle that was capable of doing bidirectional. We'll see more and more of those vehicles. So I think now it's becoming a reality. I think it was ambiguous a decade ago, but now with load shifting, with bidirectional vehicles coming on board, with more customers getting solar and storage, now the real value of smart meters is going to start to show itself.
I think flexibility is going to be one of the biggest value generators in the whole digitalization space for utilities, period, right? Like anything that touches power markets tend to, be followed by billions in value as opposed to millions in value. And so, so I'm going to ask one more question, and then I'm going to open it up to audience questions. And so this is just a prompt to get ready. Arnaud, the last question here is just for you. So some of these technologies are pretty complicated things to scale up and build. And for larger utilities, maybe that is an easier thing to go about and do because you can have more resources, you might have the staffing. Smaller utilities might struggle with some of this, right? The idea of building out these solutions. So can you, is digitalization for everyone? Is it fit for purpose for even the smaller utilities? Because across Europe, you have municipal utilities that are looking at very smaller areas. Can they too be moving things to the cloud, or can they too be integrating some of these more complicated technologies as well?
Very interesting question. I think they do. Very different problems to solve, very different capacity, as you say, to invest. But we are seeing also, kind of different use cases for this type of utilities. Typically, we are seeing, for instance, more and more community-type microgrids, for instance, which are driven by these local or municipal utilities. So those type of projects are enabled by digitization. So they may not have a lot of means to invest in the infrastructure itself, but looking at it piece by piece is one example of things that we've been able to see move forward thanks to digitization. We are also seeing some relatively small local utilities as well, investing in those technologies, but in a much more nimble and focused fashion. In general, so focusing on their key problem to be solved first, and being clear about that, and then from there onwards, engaging on that track rather versus maybe some of the broader utilities which can tackle different type of problems at the same time in parallel. So I'd say in principle, yes. And the more we move towards kind of open, flexible, interoperable type of infrastructure support from a digital perspective, I think this is enabling to also make it more accessible in general, because one deployment of some digital capabilities will host more and more features, applications, versus having all this siloed approach. When you ask about smart meter, is it overrated and so on, I put my hand down just because I think it's just today. I think it's absolutely critical, but today it's probably again too siloed of a system, right? So it has kind of its own environment perimeter from the initial use case to us trying to answer, but that needs to be much more integrated at the local level with the rest of things that needs to happen at the infrastructure level. So with that, I think is coming also this opportunity to have a much more flexibility in the type of things that can be added onto an existing infrastructure without having to make massive deployments of new devices, new communications, and so on and so on. Right, and so thinking across, which usually has some challenges with regulation and so on, but that kind of platforming approach, or having some basic infrastructure, physical and digital, that can host many services, we see that as a way forward as well, especially for these smaller customers who don't have this capability to put so many things in parallel. Right?
Okay. Any other comments? Yeah.
Yeah. So. The smart meter tried the number one use case that tried to solve is billing, right? Revenue generation for the utility. So you will need to have a meter. Now, is it smart? Is it not smart? Preferably it's smart, right? As we're talking about digitalization here. On your question about smaller utilities and if they should also engage into a digital transformation, I would say absolutely yes, because every business, even if it's not in the utilities section, it does, or it should be, or it will be in the near future, right? So therefore, there is no reason for smaller utilities to stay behind. They face the same challenges that the larger utilities face, maybe in a smaller scale. And to combine it with the previous question you asked about the architecture or the cloud, those smaller utilities, they will find bigger benefit on having their solutions in the cloud, because typically they do not have their own data center. The big utilities, they will have their own data center, they will have their IT staff, their experts. The smaller utilities, they will definitely prefer the cloud.
I would say that there is no choice. So digitalization must be not a must, a have-to for everybody. But there is not a common digitalization strategy. You have to define your fully customized digitalization strategy. Even if we agree on that the digital architecture will be, or is it now a fully decentralized one, finally, for many of the utilities, no matter what the size is, you will need a combination of edge, on-premise, or cloud computing capabilities, depending on how spread you have your business and your facilities. The core for that should be what we also mentioned in the discussion, is the flexibility of your architecture. So a very good orchestration for microservices in order to be flexible and agile enough to define new solutions for the new problems that can appear must be the core of your investments.
Cool, thank you. You started summarizing the whole panel for me, so this is good. It seems like it's all buttoned up. Okay, so over to everyone in the audience. Do we have a question from anyone here? Yes, in the corner here. I think they'll run over and give you a microphone. If you can just state your name, your company, and then your question, please.
Hi, my name is Sebastian Denis from CGI. I have 3 questions. I think they are more related to NADs. Apologize for the others, but my first question is we all agreed on the fact that digital strategy is very important, and we're going to live the maybe 4th revolution of the energy sector coming up on the following years. So we'll agree on that. How company like NADs, one of the biggest DSO, if it's not the biggest in the world, will face to find the right profiles to accompany this digital transformation, especially in a technology such as artificial intelligence or machine learning or generative AI? So that's my first question. The second question is, you can also train your own people, reskill, and accompany your people to the change management, because the biggest change of artificial intelligence is the people mindset to become a collective intelligence, and how you're gonna manage to accompany your task force. And the third question is related to the smart grid. So how, because we didn't discuss about the cybersecurity and OT architecture, so this is already a very important point of the digital strategies, and I think is one of the key elements. We'd be happy to have your feedback on that. Thank you very much.
Claire, if you want to start.
Okay, I can take the 2 first, and then the other one on OT as well with my colleagues. It's really a key issue, the skills, actually. Not only on data, actually, also on cybersecurity, also on optimization, algorithm optimization. It's basically, we know probably all of us that worldwide we have a digital skills issue. We don't find the right people. So what we have done is 2 things. We've first envisaged a growth of people that are going to be shifting different years. We're not going to hire a lot of people right now. First of all, we have already plenty of data scientists, for instance, because we hired them year after year, and we have basically something like close to, I will say, 80%. And we also have contract with a large other company to also have more people when required. We tried to skill up our own people. We tried to skill up people from data analyst profile to data scientist profile. It was not so large success, I will say. We set up a promotion of 10 people. We send them at school, let's say half school, half work for a year and a half. And at the very end, those people was able to really face or to lead some middle complexity problem, but not real huge problems. So we are going to renew a new scheme, let's say, but with different kind of people at the very beginning. What worked in the group? I mean, EDF is Enedis is part of a group, and on nuclear, for instance, they tried some other kind of profile. What they have done is that they took some people who was already engineer, with a large background in fluid mechanics, for instance, or those kind of physics, I will say, and move to these people or complete their knowledge with data, machine learning, let's say, algorithm knowledge. And this was a success. But you can do that with some people. So at Enedis, we also need to find some new ways. And this leads to your second question, which is the how are you going to convince the people with a job which has nothing to do with data? They really knew their own physics, electrotech. And when I come to them, I say, perhaps we can try to build something hybrid between your physics, your knowledge, and my knowledge. And I'm sure that we will be able to solve problems differently. And we have problems today that we cannot solve with the current electrotech approach. So we need, because if the problem was small, we will be able to do that, but the problem is now really big, and it's very hard to really explicitly say the physics. So you need to grab some other techniques, and this can come with data analysis. So that's for the second one. So we are in the path to really try new approaches, and if you have some idea, I'm ready to listen to your solution. And then for the third one, OT at Enedis is concentrated into a dedicated teams. And by the way, tomorrow afternoon they will give a talk. So it's, for instance, it's Jean-Philippe Poirier. So if you want to learn about more OT, listen to him. Anyway, OT, and especially based on what you said before, is going to be very close to data optimization, data crunching, let's say. And so we have decided inside Enedis to work together very closely. Very, very, very closely. I'm not going to do the OT work, and I'm not skilled for that, but I can bring a lot. And this is the way we are going to work, and cybersecurity is critical there. And we also have, within a few months, something called AI Act, which is going to concentrate on essential services. And so it's going to be very expensive, and also we will have to make a lot of energy if we want to put machine learning approach into those OT processes, let's say.
David, did you want to add on something there?
Just on the skills point, two things really. So I help National Grid, which is a system operator and grid owner in the UK. I sit on their advisory panel, and they often ask, like, how do we attract great skills? How does the Octopus Group bring in really talented data people? And I say to them, I think particularly the networks and the system operators have some of the most interesting data problems in the whole world right now. Like, if I was coming out of any sort of scientific degree, I'd think, where do I want to work? It's sort of good for the planet. It's a fascinating problem. It touches everybody, so it's sort of relatable. You can talk about it at dinner parties. And the inability to hire is actually about making these jobs look interesting. And so that's about like empowering people to be able to use the tools they want, work on the data they want, working in what feels like a tech environment, paying people, you're never going to pay sort of FANG salaries for these kind of roles, but being honest about like what do you need to pay really good machine learning people, and so I think that's for the sort of data science and machine learning. For the data analyst roles, for people who you want to just be able to like make sense of your business data and answer quick business questions, I think we're about to go through a very fast paradigm shift with Gen AI. So from the tools I'm starting to see, I think it's my team will kill me for talking about Excel on a data science panel, but I think it's the same paradigm that Excel and spreadsheets opened up, which was it allowed a business user to suddenly interact with tabular data, write little formulae, build models that they couldn't do before because they had to have a coding language. And Gen AI is going to have the ability to look at your data, understand its context, and you'll be able to ask a natural language question. It will be able to write the SQL, visualize it for you. So I think I don't think we're going to need quite as many data analysts. We'll need people who can think about the right business or system question and ask it in the right way, and Gen AI will help do the work for us.
Okay, so yeah, computer science helping us solve computer science problems. So yeah, that's always good. Okay, so any other questions from the audience? I saw a few other hands up earlier. In the back corner there.
Hello, I'm Crystal from Fluvius, Belgium. I have a question to Zozan. Sorry, you told that simplicity is your greatest friend. I love it, but if I see that the regulation and so on is sometimes so difficult to set up a new kind of systems that is more simplicity. Do you have any tips for us how we can do that? How we can influence them?
That's a question for you, right? For Juan?
Well, my experience is that fortunately, in most of the countries where I have clients, they define their own regulation. Okay, so they have a level of freedom that we don't have here. Okay. Having said that, it's clear that as much simple you can do it, the best for operational efficiency. So the definition of your architecture should be fully aligned with that. Regulation is an issue here. We have been talking about regulation in Europe in the last 20 years, and we still are facing problems that technology are able to solve, and the regulation it's preventing to do it. When talking about flexibility, when talking about adding new capability to the grid, regulation sometimes is an issue, and that issues we don't have in Middle East.
I think regulators can be quite rational, actually, if there's data, right? I think I'm just hardening your point here. If you're coming with sort of data and saying, if we simplify in this way, we think we can save the overall system, X%. I've found regulators to be quite reasonable in that respect. The other thing I've found is there's sort of the regulation, which says one thing, and then there's years and years and decades worth of interpretation on top of that regulation. And so every so often it's helpful to go back to the original regulation and really understand what did it actually say, not the years and years of interpretation that were built on top of it, but what does the regulation actually say? Because I often find there's a big deviation between sort of the internal understanding inside of an organization of the regulation and what the original intent was.
Yeah, it's clear. My colleague put the focus regulation sometimes is preventing to do things, but sometimes we we are captured because of our existing silos architecture. Okay, sometimes if we are able to define a flexible and global data layer, most of the simplicities that we can have in mind will not need big changes in the regulation.
So we have time for one more question, and then we can wrap. I think there was a question here in the front.
Hi, Lorenzo, freelance strategist. I have a question for all of you, like a bit of consensus question and then a follow-up. So would you prioritize simplicity or unification of data?
Can we say both?
Yeah, prioritize. It's not which is more important, like which would you want to have first?
So simplicity or unification?
For me, simplicity. The unification of data will take time, and you have to look for your operational efficiency.
Without meaning to be difficult, I would say they're orthogonal. So I don't think you can. I think unifying, putting your data in one place. Ultimately, your data is there to ask questions of, and generally, you want to be able to ask questions across lots of domains because they're richer questions than just being able to ask in one silo. So by unifying, you are actually making that question answering process a lot simpler. So I think they're orthogonal dimensions to how you organize your data systems.
Actually, it's not the data that you have to simplify, it's the processes of your company. And then your workflow of important data, because the key issue is define what is important when you want to crunch the data, needs to be defined when you review your processes or want to simplify your processes.
It's this change management that's stopping things from happening more than anything. It's the people.
Yeah.
It's the organization more than the data or the information. It's those processes that are key in any organization.
People and old processes that the utilities then need to rethink, right? And to simplify things. Yep. And you should unify your data in a simple way, I would say.
So it seems like the answer is it's complicated.
Yeah.
And your follow-up, just quickly, was?
Super quick, mostly sparked by something Claire said. If we go through process in which we go from through machine learning to understand insights of data, right? Don't we risk to go into confirmation bias and genetic fallacies in the logic through which we arrive to the conclusion through the fact that maybe our data set is not encompassing all the possibilities? And how do we face these issues?
Just quickly, Claire, if you have an answer.
Quick will be hard. Yeah, I guess when you really start to build your machine learning model, you have to spend a lot of time not trying to grab the data. Where is the data? Where I'm going to quality? You need to spend a lot of time ensuring that your data will not bring some B. And this is really key because any kind of algorithm that you will use in machine learning will not be able to remove the BIA from the data. So you really have to work there. And when I was talking about efficiency, since the beginning in the process of building some data services, is that I want the data scientists, for instance, or data analysts, when they work with those kind of data, to spend time on trying to figure out if their data will bring a bias or not. Not let more there than in trying to grab the data, ensure that the quality is there, blah, 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 blah.
Okay, so I'm going to ask one last question before we go. I think there may be companies looking in 2024 to redevelop their digital strategy as we kind of see this shift happening in the sector, both in terms of the increasing salience of the grid and also these new technologies. So imagine there's this hypothetical company who's crafting their digital strategy, and they're looking for an adjective, a word, to include, a single word to include in their digital strategy. I'm wondering if you can each volunteer one word that you think is one of the interesting aspects that we need to include in a digital strategy. And so maybe, Stuart, starting from here, if we can just work our way down.
Yeah. Sort of biasing from the brownfield side, I'd just say modernization of your asset, your existing assets.
Modernization.
Yep.
Arnaud?
Flexibility, I believe, is really key.
Data-driven in one word.
Simplify your business with hyphens between them.
Speed of migration with hyphens between. Speed of migration.
I would say operational efficiency.
Agility.
Agility.
Being agile.
Well, there you have it. Can you guys give me a help in thanking my panelists and ending the session?